Okay. Hello, everyone. Good afternoon from this time zone, and morning and evening, depending on which time zones you are. A big thanks to the organizers of this really fruitful event for having us on board. And also many thanks to Emily, Bertil, and Giorgio for being our discussants at the session. Now, I'm just going to briefly introduce what we have in plan for this session, as I'm going to be chair of the session. So the plan is to basically have two short talks by Angela and by Susie, followed by three of our discussants, and there will be plenty of time for the open discussion for later on. Before all that, I just wanted to say a few sentences regarding this whole project that we are going to present. Now, we are all, let's say, aware how exciting the field that we are working in is, both MEG, EEG, ERP, and how many valuable insights we got through using those methodologies from our own research and from the research of other people. However, we also are very well aware that there are issues in a field. And again, we basically saw that through our own research, but then also through different sessions at this conference and in our conversations and exchange of information anyway. So basically, one of the nice things that I saw personally was how Aina Pius basically showed us this graph with impressive exponential growth of ERP, EEG papers in the field. And there are numerous others inspiring talks, not to leave anyone like Yuri Pavlov and so on. And basically, I just wanted to say that our approach was to get into specifics of the problem by doing a thorough meta-analytical analysis, which will be presented by Angela Shoshkic, which will be a very first talk. And after that, based on what Angela is going to be presenting, we will move on in presenting Susie's talk, which is how to do a better, and what are basically the better ways based on this meta-analytical research in our view. And we know that there were numerous attempts prior to this, and we are really open to every feedback that you can provide us, how we as a field can progress in this way. So that's all for the very beginning. And now I would invite Angela to start with her presentation. So Angela, please go ahead.
Okay, I will share my screen. Okay, can you see my screen? Vanya, can you see my screen? Is it okay? Okay, I see. Okay, so the first, my talk will be an introduction into the topic that we will discuss today. And I'm here to say a few words about the research that we did in the past few years, and some studies that we are currently doing. And it all starts, I'm sorry, before we start with the talk, I would like to thank our organizers for inviting us here and for making us feel very welcome and enjoy the great program and organization. We'll be having a lot of fun these few days. So we just wanted, sorry, can you hear me better now? Hello? Sorry. Okay, can you hear me better now? Yes.
Okay. Angela, yes, we can hear you now better. You just need to get closer to the microphone, otherwise we don't hear you well.
Okay, okay, sorry. So anyway, I was thanking our organizers for inviting us and for the fact, oh, this is going completely crazy. And because we're having a lot of fun and learning a lot of new stuff at the conference. And other than that, I also wanted to introduce our team that you will get to meet a bit later. There is two of us from Belgrade, Vanya and I, and also Andre is our colleague from Belgrade. And we have a team from Singapore, Han and Susie. And we also have Emily, who is from San Diego. So we're a small but international group. So this whole story starts with the fact that ERP analysis is a very complex process. It takes a lot of steps to get from the raw recordings to the point of data analysis and interpreting the results, which is something I learned when I joined Tanya's lab for my doctoral project. And one of the first impressions that I had, and which was probably shared by a lot of other doctoral students and younger students who get into the ERP, is that there are actually a lot of decisions to make, and at each step you can take a different route, and you start to feel lost about how you will go and which direction you should take. And when you start looking for the answers, you realize that there are a lot of great guidelines. There are a lot of papers that are published either on specific questions, how does filter influence your results, or there are more general papers, which is guidelines for good practices. But all of these questions necessarily leave a variety of options open to you, and you can still take many roads even if you follow the guidelines that are given. And the question that we had was, okay, can we be sure that running all these different analyses that are appropriate will yield the same results? So if we have a high pass filter cutoff at 30 hertz and 100 hertz, is it the same? Is it not the same? Okay, this one doesn't differ very much, but for some other decisions, it could be more important. And by the way, the image that we see here, we will come back to later. It's an actual graph of branching of only some selected decisions in one analysis. And it starts with 1 point, but as we progress later, we end up with 864 different points. So the first the one question that I want to talk about today is how much variability is there in the peer-reviewed literature? And this question can be separated into several other sub-questions. I'm sorry. That is correct. So, okay, is it better now? Vanya, can you tell me?
I think it is much better now, but the problem is when you turn your head to the left, then the sound goes off and we can't hear you clearly. So you need either to keep straight and not on the side, otherwise we are losing you at this point.
Okay, I will do that, sorry. Okay, so our question of how much variability is there in the peer-reviewed literature, if we can take these many different routes, can be separated into a few important questions, such as how much methodological variability is there among studies which would be expected to follow similar procedures, such as studies that have similar design and go after a similar ERP component, for example. Which practices of these are the most prevalent? And then we can also ask, how often do researchers deviate from the guidelines for good practice that we know of? And which of these deviations are the most common? And finally, we can ask ourselves, how often are descriptions of methods and analysis insufficiently detailed? So how often do we lack information needed to, for example, replicate or evaluate a study? And which are the principal areas in which improvements are necessary if there are indeed spaces in which there is not enough detail? So we set out to try to answer this question with a systematic review of literature, because we were not sure which routes to take in some situations. We wondered about what do other people do, and because this question is very broad, we decided to narrow it down to the N400 component recorded in neurotypical healthy adults and recorded in response to one type of stimuli, and these are picture stimuli. We picked papers published between January 1980 and June 2018. The 1980 is the year of discovery of the N400 component, so it didn't make sense to go earlier than that. And we picked two large databases, Web of Science and PubMed. And we made a selection of papers from this initial pool, which was conducted by two independent researchers so that we remain as objective as possible. We extracted information on methodology from all these papers on 74 properties of study design, equipment, data recording and pre-processing, measurement, statistical analysis, presentation of results, and on whether they provide supplementary information or not. And just to demonstrate how much information there is in such a table, given that we had 132 papers and 74 columns, it gave us almost 10,000 different cells of content. And this context was extracted by two independent researchers and then merged by joint work of two other researchers, because it turned out that in a lot of situations we really needed to discuss and see what was exactly done if it was not unambiguously reported. So this is what the Prisma flow chart looks for our project. We started with 1,508 studies, and we ended up with these 132 papers through a few steps of removal of publications from our initial pool. I will present briefly the results. When it comes to transparency in reporting, there were some variables for which most studies or almost all of the studies reported appropriate values, and unsurprisingly, these were the number of participants or the number of trials and what analysis window was used to measure the N400. But even in this case, there were papers that did not report this information, even though it is some of the most basic information about a study. And there were other measures. For some of them, they are in the mid-range here. These are values such as what was the analysis montage, what was the amplitude measure, what was the baseline used for baseline correction, and these were reported by most of the studies, but not all of them. And in some cases, it is again concerning because these are again really important details, such as which electrodes were used to measure the N400, and as you can see, this was reported in about 85% of all cases. Then again, there is this third area on the top, which are the most problematic fields, and among these fields we have online filters, details about filters that are necessary to replicate them in a lab, such as filter slope or whether the filter is whether the filter cutoff point is half power or half amplitude. So these are again details that are more fine-grained than, for example, the analysis window for N400, but they are still relevant to decide whether a study was conducted well and to see to replicate a procedure if you are trying to do it in your own lab. Another thing that the second question that we were interested in that I mentioned was the issue of consistency in methods. So what are the things that we agree on, and then what are other things that we don't agree on and where we do different stuff? And we could see about three groups of characteristics. And these are things where we have the most consistency when there are the most when the majority of researchers is doing the same thing, and some of them are for better, and some of them are for worse. We agree on that it is not good to use blood filters. Very few studies do it, especially nowadays. It's been something that has been often cautioned against. But also, when most researchers are testing electricity, and they are using the more strict greenhouse geyser correction for this. When it comes to amplitude, in most studies, I think about 70% of all studies, M400 amplitude is measured using mean amplitude. And unsurprisingly, mean mass studied reference is the main reference for measuring M400 amplitude, about 75% of all cases. But there are also some not so good things that are very prevalent, and one of them is not using appropriate corrections for multiple comparisons. And we will get back to that in the next slide. There was the second group of characteristics where there is a variability, but some common options can be identified. Such thing is baseline. When we are talking about baseline, we register about 11 or 12 different baselines. And the most commonly used one was 100 milliseconds, which was used in 43% of the studies. Yes, the studies are consistent in not correcting for multiple comparisons, yes. So when it comes to the group that has the least consistency, there are a few diseases on which almost every paper took a different route. One of them is artifact correction and rejection procedure. We had a lot of trouble in how to even present the results on what do people do with artifact correction and rejection, because it is very diverse. And other such properties are average reference. The papers that do use average reference make it based on between 19 and 144 different electrodes. So actually, there is this issue that when people use average reference, it is not the same reference. Maybe it is approximately the same for studies where there are more than 64 electrodes, but that is not the case for all of the studies. And finally, we have measurement latency and analysis montage, which were, again, very diverse across studies, and we will see this soon. Sorry. Do you hear me better now? I apologize.
Yeah, yes, we do. Basically, my impression is when you turn towards left that we are losing you. So if
sorry.
you could try to keep it straight or to the right. Okay. Thank you.
That, but my second screen keeps distracting me. Sorry.
Yeah. Okay. Thank you.
Well, and I'm looking at the question. We did not look at the sampling rates. This would definitely be relevant for the pre-stimulus baseline. There are other interesting properties that we didn't have a chance to look at as well, such as the way the data is visualized and so on. Let's move on further to the adherence to recommendations for good practice. We looked at quite a few papers on different methodology, but I'm here emphasizing the guidelines for good practice that have been published and that we looked at the most. So Donchin et al. Paper from 1977, Kyle et al. From 2014, and Picton et al. From 2000. And when it comes to this field, several problem areas have been identified. For example, while we know that it depends on the study how big the sample should be, I think we can generally agree that having fewer than 10 participants in a study is little. And this was the case with about 10% of all studies. And similarly, 1/3 of studies had fewer than 30 trials averaged per condition. And also inappropriate filters, I mean, in the sense of very high pass filters or very low pass filters, were used in about 10% of cases each. And there were other issues such as baseline related issues, which were difficult to quantify, but there were things such as baseline noise and other problems that we could identify in papers while we were going through them and analyzing them. And one of the probably most prevalent challenges is that measurement and analysis decisions were often data dependent. And as somebody mentioned, I think in a few sessions earlier, it is not a problem that we have exploratory research, but if we treat it as confirmatory, it's then our p-values don't tell us what we think they do, and there is also the issue of double dipping, of using the same data set to decide on a window and then to analyze it, and this was very frequently registered in the papers that we were examining. So here is an example of how diverse the studies were, and also of an example of how we can use the previous studies to try to extract some meaning and recommendations for future research. On the left side, we have the M400 latency windows by study, and we can see that they are very diverse, and in some cases there is no overlap, and it is similar with the electrodes that were used. On the right, we have all the electrodes that were used to measure N400 amplitude in the studies that we reviewed. So you can see that they are all over the head and that there is a lot of them. And we were, and this is despite the fact that N400 is a component that is relatively stable in time, and that is relatively stable relative to where it is registered. And if we try to see which of the time windows and which of the electrodes were used most often, and we weight this information by the number of participants in the study, we came to a conclusion that the best measurement window was probably 300 to 500 milliseconds, and the electrodes that were the most frequently reported to show the M400 effect were F3, FZ, F4, and then the same for central and parietal electrodes. Okay, so I also want to mention two projects that are in progress. One of them concerns the question of, is this observed variability an issue, in the sense that would it produce different results if these people were taking different routes? And we could also wonder about other components, because these are results are only about the M400 component. Sorry, this, never mind. I'm not sure why this. So when it comes to the first question, it is a study that we hope to have a preprint posted soon. But we wondered about what would happen if we took the same study and went and took different decision routes. Would we get the same results? And as I mentioned, we found 864 different pipelines. Only if we would choose the most extreme and the most common decisions that we found in our systematic review. And of course, we couldn't test all 864 of the pipelines. So instead, we picked the 14 of these pipelines and we compared them. And the results show that the main big robust effects, such as the M400 itself, were always there regardless of the route we took. but the effect of interest may not be, because we are usually not interested in whether there is an M400, but does the M400 size, magnitude size, differ from one experimental condition to another. And this could be more, this actually is more sensitive than the presence or the existence of the M400 itself. Another thing that we found was that there are differences in effect size, effect magnitude, statistical power, depending on the pipeline which one takes. So it is probably not useful to check out different routes and see which ones would give the best results. And we give some recommendations on which of the decisions improve or decrease statistical power, effect size, and so on. The second question that I mentioned is what happens with the other component, and I would like to ask our colleague Han to briefly present the study that we are working on now, and which is also a systematic review. But it concerns different components recorded in different populations. So we are talking about MMN component in developmental studies. Can you please bring Han on stage?
For the conferences, for the organizers, could you please bring Han on the stage? Thank you.
Hi, and is it my turn?
Yes, Han, we hear you well. So yeah, you can just jump in. Angela, just introduce your the project that you will be presenting.
Yeah, Angela, can you go to the next page? So, me and Susie are working on systematic review on mismatch negativities, which is particularly on audio mismatch activities. So we are hoping to particularly looking at the infant and children age, and we study on OSF, but the study is embargoed, so it's not public for yet. But we have a screenshot here, which you can see, and it's our preparation document. And the progress of the project is like from the database searching, we started from over almost 13,000 papers, and so we already finished the abstract excluding, which excluded 9,000 of the papers. That's because we are collaborating with a medical librarian. So most of the paper are clinical papers. And then we are now doing a full text screening on about 3,200 papers. And for this one, we are mostly adapt Angela's M400 systematic reviews, and we also particularly set up some data exclusion details for. Oh, Angela was disconnected. So we also look at some paradigm and details specific for MMN, which is an audio outboard studies, and we're looking at specifically looking at how people extract the standard and deviant and values from the paradigm, and we already found this, a lot of inconsistency in the existing literatures. And hopefully this systematic review will be finishing next year. I think it has to be next year, so we can bring more insights of this field and how this part of components was conducted. Thank you. I'm waiting for Angela.
Thank you very much, Han. And now if we can have Angela back again, please. Thank you.
My computer crashed.
Oh, okay, but we can now hear you and we can see you. So would you like to try to continue?
Yeah. I'm sorry about this.
No problem at all.
Okay. Can you see my screen?
Yes.
Okay,
we can see the screen and we can hear you. Thank you.
Okay, I assume that Han told her part. I'm sorry about missing it. And should I skip forward? Yeah. Okay.
Yes, please.
Okay, then actually I was only about to finish and give my mic to Susie, actually Vanya. To summarize, we were interested in the studies that we talk about our ability to replicate methods based on the papers that can be found in the literature, and also about whether we can replicate the results, because if we don't have sufficient methodology detail, then we cannot be sure that the differences or the similarities in the results between the new study and the replication study are due to methodology differences or due to something else entirely. And we see that if we want to have really replicable research, there has been a lot of progress, but there is still progress to be made to improve reporting and to increase the level of detail in reporting. And additionally, I talked about some other questions, such as the robustness of results to variations in methodological decisions, the deviations from the guidelines for good practice, and how we can make guidelines for a priori methodological decisions based on previous research. And I mainly talked about the challenges, but we are actually here today to talk about a proposal for a solution. And I'm posting here, and Vanya has posted the link to the ARTEM-IS project, which is our next talk. So I would like to ask Vanya to actually to give mic to Vanya to continue further.
Thank you so much, Angela, and also for managing to overcome all the technical difficulties. Very much appreciate your presentation. Now, for the whole crowd, after we heard about these three big projects that our team was part of, it really involved quite a lot of heavy lifting, and we are still working and progressing on two of those projects. Only one was finished. Based on all those insights that we got working on this really like a huge project, we think that we actually got better insights and that we are in position to maybe now know better how we can move forward in a field. So speaking of our vision, how we can move forward, I would like to invite the organizers, or actually to ask organizers to invite Susie on stage, because she will be presenting our vision of how we can as a field move forward based on the insights that we got so far. And we keep following all the messages that you're posting on site. Whilst the organizers are bringing Susie on a stage, I will take the opportunity to thank you so much for your support, and especially for your comments and questions that you're posting as we talk. And I love Susie's suggestion for the bigger questions. If you could pause them, ask as a question at the bottom part of it, it would be great to discuss some of this further, because we would really appreciate any insights, both positive and negative criticism from what we've been doing so far, because we really are eager to basically improve all of the stuff that we can. Susie is with us, yay! So now I'll give word to Susie.
Okay, thanks very much, Vanya. Let's see if our screen sharing works according to plan. So I'll ask a couple of questions as I go along, just to check that we're able to share screens. It looks like we have too many video sources on the stage at the moment. Oh, there we go. That seems simpler now. So let me try sharing this screen, and I share the main one, and then I will begin the presentation. So pop this up here and display. So Vanya, can you see my slides? I can't see the chat. So
yes, Susie.
Okay.
No, voice looks perfect, and we hear you well as well. Thank you.
Okay, so what I plan to talk to you about today, and I plan not to take very long, because I want us to have plenty of time for discussion, questions, and for your insights and opinions about how we can best make use of the community of expertise we have together in this room in order to make progress on what we've just been talking about. So Angela has laid out the groundwork really clearly, that in our previous research, when we've been trying to use these data-driven approaches to say, what is the state of the literature as we know it? Can we systematically review the literature to find out about best pathways or combinations of tech or combinations of approaches that work well together? How can we pull from the existing literature the most statistically sound summaries of a particular effect of interest or something along those lines? One of the biggest challenges that we found is often the methods sections of the published papers are written so inconsistently that it's very hard to extract that information, even as a human who has worked in the field of EEG and really understands what it is that people are trying to describe. There are often so many omissions and errors, it's very difficult to know what people have actually done. And part of the challenge here is the ambiguity of using written language to describe highly technical details in a short space of words. So we all know the pressures of publication constraints. So what I'm going to talk about today is how we might culturally address this problem as a community of experts. Now, we've had on stage over the past couple of days an amazing collection of people who are really at the cutting edge of pushing for best practice and pushing for data archiving and sharing of code and all of these wonderful things that will help us get towards this goal of being able to do this kind of large-scale evaluative work in a more automated or a more standardized way. But I also am aware that we have, if the count is correct, around 1,200 people joining us today. And it may be the case that not everyone is at that level in their own day-to-day EEG practice. So there is an intermediate stage where you may be publishing papers, you may be working in this field, and maybe you work in a lab that isn't prepared to or cannot, for some ethical reason that I can't quite imagine what it is. Maybe you're not really set up to share all of your data and your code. If we can, at the very least, work on getting our reporting up to a level of accuracy where we can do this meta science, then every contribution to the scientific record counts for more. So I'm going to be talking about some cultural things today. And I'm going to start with lessons that we can learn from two different fields, aviation and surgery. So I'm going to start with something that looks like a catastrophic error. Some of you may have seen this photograph before. And what I want to share with us all is the idea that whenever we have humans working in a highly complicated environment, there's a chance for unforced errors, like the unforced error that led to this plane not landing in the standard fashion. The way the aviation industry has solved this problem, or one of their approaches towards solving it, has been the use of pre-flight checklists that are mandated for every vehicle that goes in the sky. Now, these checklists have been around for a long time. This particular one was developed or reported on in 1993. And I just want to highlight some of the key features that are really interesting when you think about the way that these tools are designed and how they are used, because some of them have relevance to the work that we do, even though we don't necessarily have passengers' lives at stake. So I've just highlighted a few of the key features, the guidelines for what a check that is designed to reduce errors could involve. So to translate them more concretely into our field, the first point is that checklist items should contain actual values, not simply a statement that an item has been checked. So when we think about those best practice guidelines for conducting and reporting on EEG studies that Angela introduced us to earlier on, there are many, many checklists that say things like, describe your filters clearly, but the tool itself doesn't provide you with the format in which reporting that filter could be done to such a degree of precision that it cannot be wrong. So we could potentially take this piece of information forwards in designing a tool that helps people do that better. The second point is that long checklists should be subdivided into procedural sections. Sounds pretty straightforward. Checklists should be sequenced to coordinate with providers of external information or configurations. And we can think about that in terms of how well we coordinate our reporting framework with the outputs that can be provided by hardware suppliers or software developers or people who are manufacturing individual electrodes. The last stage of a checklist should be a declaration or a call to all parties involved that the checklist is complete. And we can think about ways that a reporting template might help us to do our own validation checks of whether the reporting that we are attempting is accurate, or at least filled correctly, filled in a way that is not internally inconsistent at the very least. Checklists should also be integrated with performing key tasks. And I've been super excited to see at this conference how closely many of the teams are aligning with this goal in their own work. So the work of Kubidas, who are setting up infrastructures within which data and code sharing can be facilitated. If part of the reporting process is integrated with the process of actually doing your science, then we're much closer to this goal than we think. And finally, there's the notice that everyone involved in the work of aviation needs to be aware that when there are pressures, so this might be time being scarce or manpower being scarce, and not necessarily a direct incentive for performing the checklist function, the pressures that exist in that environment can cause substandard performance, and checklists are often one of the first things to go. So maybe you have worked in a lab where checklists were deemed an unnecessary luxury, or maybe you've worked to a publication deadline where you thought that checking all of those minute details in the methods section wasn't really worth it, because if it was sufficiently important, your reviewers would pick it up. So you probably know what I mean about resource scarcity, but that also includes word counts. Now, it's not just aviation that has implemented this idea of the checklist as a way of reducing the number of unforced errors. The World Health Organization has also, after conducting a series of reviews in 2004 into surgical safety, produced a series of clinical practice guidelines. Many of us will be familiar, especially this year, with the clinical practice guidelines around hand washing. But in 2007 to 2008, World Health Organization also developed a surgical safety checklist. Now, this was designed for surgical teams to complete before they begin operating on a patient as a way of reducing unforced errors. Now, in the surgical safety checklist, there have been a bunch of studies designed to see whether experts who really know their stuff but are forced to fill in a checklist actually reduce the numbers of errors that they perform, doing highly routinized tasks in a highly routinized order. And it turns out that even in the very complex context of surgery, using a standardized template does indeed reduce errors and reduces mortality. And I should say that this is just in the first 30 days of implementing our checklist across 8 hospitals in 8 different countries. Follow-up studies have looked at what are some of the challenges to introducing these kinds of checklists as mandated practice in different environments, including initial reactions from different stakeholders in the surgical procedure. And one of the things that's often been noticed is that it's often the people who have the least prestige in the research environment who are very supportive of these checklists because they are genuinely helpful, whereas some of the people who are more experienced might show some form of resistance to them because they're confident in their own knowledge structures. Some pushback is sometimes observed when it is perceived that there's duplication between one checklist that has to be completed and another checklist that has to be completed somewhere else. So we can also learn from that experience. The takeaways from some of these studies, though, have shown that unsupportive leadership can be a barrier to best practice in following guidelines that are beneficial to others. However, this can be mediated by having best practice champions. So among this community of people who are gathered here to think about EEG methods and think about how you're going to write your next paper, you might be one of those best practice champions who can help lead the way for the community to report on our science in a more accurate way. Another thing that's becoming more important is recognizing that there may be shared roles in who does what or who reports what aspect of the work that has been done, but it's a shared responsibility across the entire research team. So you may have worked in a lab where different people at different levels of seniority may have taken a different level of attention to the methods section of a particular paper. And it's worth thinking about whether or not there are tools that can help us communicate more effectively across those methods, those methodological divides. It's also been noticed that having external audits of some kind helps, that gives feedback to the team on how well they are performing their reporting. So we've already had comments from editorial teams so far saying that as an editor and possibly even as a reviewer, we often ask for additional methodological information. If that methodological information were provided in a template format that were human readable and reduced the likelihood of errors, then those checks would be easier to perform, and the template itself would give feedback to the writer that they have performed their writing correctly. The other point that's very important for us to remember is that all of these tools seem to work better when the community who has to use them is involved in the development of the tool, so it best suits their need. In the case of surgical checklists, this means hospitals making their own adaptations to tools before they use them. Which kind of brings us to one of the points of why this ARTEM-IS project is being presented as an incomplete draft. So Vanya has shared already the link to our ARTEM-IS project in the chat. I can't see it at the moment, but perhaps she'll post it again. Anyone who wants to look at what we're proposing to help improve the quality of research reporting, we have a draft document there that we're hoping to use as the seeds of a discussion on how we as a community can make this tool better and better integrated with some of these other platforms that we've been hearing about this week. 10 years on from the World Health Organization Safe Surgery Checklist, it's still noted that hierarchy within teams can be quite a barrier to effective communication and effective completion of tools that can reduce errors. Other barriers include perceived time cost and perceived extra workload, and a perception that sometimes tools that require filling boxes are meaningless tick box exercises. However, it has also been noted that providing additional training or additional background to how the tool benefits the stakeholders can make change in that perception of whether or not ticking the boxes is a worthwhile way to spend your time. Finally, in medicine's in lessons that we can learn from medicine, it's also been shown quite concretely in surveys about the adoption of medical checklists that some of the people with the greatest deal of expertise have a tendency to overestimate their knowledge and their procedural recall of fine-grained steps or details that they use in their daily practice. By which I mean, if you're very expert, you might assume that you perform your tasks correctly, but objectively, when you're observed by another person, you may perform those steps incorrectly. Or in our case, we're talking about reporting on our scientific achievements. You may miss steps in your verbal descriptions in your scientific papers. So, taken together, the important takeaway is that checklist type behavior or templates that help us perform our duties to the best possible level of precision do help reduce errors. And importantly, they don't just reduce errors in the hospitals that decide to adopt them as some kind of placebo for good behavior. Within those hospitals that have adopted the checklists, mortality rates are lower for the teams that use the checklists and the teams that use them consistently and correctly. So, altogether, brief overview of the things that we can take away into our own practice and the development of our own tools. Checklists should contain actual values, not statement that an item has been checked. Checklists should be integrated with actually doing your job. Checklists should be sequenced to coordinate with other information sources. The last stage of a checklist should be the completion of the checklist itself. There are production pressures on all of us, but we can probably help our community to do better if we acknowledge that hierarchy can sometimes be a barrier. Everyone is involved in this work together, and our best practice champions can lead the way and help us learn how to do this job in a better way together. We know that the perceived workload and the perceived time cost of filling an extra form before you submit your manuscript for publication seems like just more work to be completed under some circumstances. But if our tools are designed well, they should actually make reporting our methods easier rather than harder. And on top of that, we really do need to work towards community buy-in. So our project has brought these concepts together under the ARTEM-IS framework, which is moving towards an agreed reporting template for these fine-grained details of EEG methodology in some kind of an international standard. And we believe that if we can come together as a community and decide what are the key features that can be filled in ways that are unget-wrongable, then this will help to improve the clarity of the scientific record, improve the accuracy of the documentation of what we've done. It can provide supplementary documentation. We don't expect this kind of template to exist within the traditional journal article. This kind of a template brings broad benefits to a wide range of stakeholders within the community. So not just those who conduct research, but those who build research equipment or processing pipelines, and also those who read and review and edit for EEG journals have a second way of evaluating whether or not there's clarity in the scientific record. But we do recognize that this takes a community effort. So where are we today? These are our 5 points. If you think you agree with these 5 points, then the first step is that you can check out our ARTEM-IS statement, which is merely a reiteration of these 5 points, that it's going to take working together to make improvements on the accuracy and clarity of the scientific record. And if you become a signatory to this ARTEM-IS statement, that is going to act as a contact point for our next round of broad community consultation, where we can work together on making these tools the most effective for all of us. So I've mentioned that we've been learning from aviation and from surgery. I'd like to highlight just at the end that what we have at this stage is a draft template. I believe Vanya is sharing the link for the draft template. It's in a very technically sophisticated Excel document at this stage. And the idea is to get this conversation going together so that we can combine our efforts. We're hoping that some of you who are with us today will go on to become our best practice champions. And we've got our eye on you for the large collaborative kind of EEG projects. And we also know those of you who are developing tech and developing software. We'd love to have you in the room as part of this conversation as well, so that we can make the best tools for all of us to share. And on that note, I'd like to thank you all for your time and turn over the conversation to some of this community discussion.
Thank you so much, Susie. And now, after we heard what's the vision of our team, it would be really lovely to hear some of the really excellent people from the field, what they think about this project. And after we hear from them, we would actually really love to hear from the whole crowd, both positives and negatives. As we said, we are really, really open to all the feedback that we get from this conference. So the very first person that I would like to invite on stage is Emily Kappenman. And so if organizers could please bring her on stage to join Susie and me. Because Emily was actually providing feedback right from the start of this project, and she was really valuable for both sides, in both criticizing and giving support. And I really personally and all team look forward to hearing what she has to say now that we actually moved away from the very beginning, when there were so many issues, how to start, how to deal with all this bunch of data, and where we can move with all that. So Emily, thank you very much for joining us. It's your time to criticize us.
No, this was great. Thank you for inviting me to be here. I'm excited to hear about this project, and thanks to all of the speakers for really giving very clear talks that I think outline some major issues, a few fundamental issues that I think we've all felt personally as EEG researchers. One, just how do we make these decisions in analyzing our own data, right? So we have these incredibly rich data sets where we can choose lots of different analysis methods and parameters. And I think that Angela's talk really demonstrated how much we all differ in our opinions on what are the best processing strategies. And so we've all kind of experienced that frustration. And so I think the need is very clear for more of these types of studies that make it clear how much variability there is in processing steps used in the field. And more research is needed needed to really give people data-driven guidelines for how to make those decisions. So I think that's one of the really important consequences, particularly of Angela's talk, that I think many of us have experienced, particularly when we're younger researchers and really struggle to know, how do we choose these analysis parameters that we need for our data sets, and how do we do so in a way where we're not biasing our results. So that's one major issue that I think was very nicely illustrated, that significant variability in the field and how much work we still need to do on that topic. The other thing that I think was very clear that we've all experienced as well is the frustration of trying to write up our own methods sections and make sure we include those details, and how do we have any sort of consistency when journals differ in formats and in length requirements, and just making sure that sort of difficulty we all go through in writing up our own papers, and making sure that we're including that information. So that's something I feel like we've all kind of shared that struggle with. And then, of course, we've all had the frustration of trying to read someone else's journal article when we're really interested in their study, and we can't quite understand what they did in order to really fully evaluate their results, or to try to replicate their study and build on it in our own laboratories. And there have been some really great efforts over the past decades that have really aimed at trying to make it easier for researchers to know what details to include in their papers. And Ina, who was here, has been involved in that. Andreas Kyle, I saw, was on here. He's really been involved in that too. And I think those efforts have helped in a lot of ways, but I think you've nicely demonstrated here that just providing those guidelines for people, providing a simple checklist as SPR has done, isn't quite enough to get people over that hurdle of actually implementing this in their own research. So this is something I've thought a lot about, and how do we actually encourage people to do this? And I, of course, never thought about it from the perspective that you illustrated and demonstrated, Susie, with how do we actually think about this from a perspective that's worked in other fields that's quite a bit different than what we've tried so far. So I think that is sort of the biggest next step, is how do we help people do this in a way that makes things easier for them, not harder for them. And I think, and makes people actually want to use this information when they're submitting their journal articles. And I think you nicely demonstrated how beneficial that would be to all of us as researchers in this field, where we have to rely on other people's data and results to drive our own studies. So I think it's great. I'm really excited to hear what other people in the community think in terms of, what would it take for them to start implementing this in their own research, and how do we kind of come up with a way collectively to really encourage people to do this. So thanks for those wonderful presentations.
Thanks.
Thank you so much. Yeah, indeed.
Sorry,
thank you so much. Yeah, sorry, Susie. Thank you so much, Emily, for your feedback. And I would love, just like immediately to continue commenting, but I would, before any of us start giving comments back, invite Bertil someone, if she can join us to hear her opinion and her comments on what we presented so far. So for the organizers, could you please bring Bertil on stage? Thank you.
While we are waiting for our next discussant, there is one written question that has come through directed towards me, so I may as well answer that while we're waiting, that asks, I suppose using the checklists in aviation and surgery is mandatory and using them is enforced, right? Do you suggest checklists in neuroscience should be enforced too, and by whom? Would they still be useful or not? Now, if you're familiar with the medical literature around systematic reviews or clinical trials, you will know that there are procedures in place where you will struggle to have your clinical trial actually published unless it's been registered with a certain national body before you began it. So there are models in our field for no publication without documentation. And if you happen to be on an editorial board at a journal, there is a golden opportunity here to potentially help your papers that are published in your journals be the ones that are replicated, be the ones that are cited more because they're being replicated, and to help them be the papers that contain the best scientific evidence because it's the completest scientific evidence. So I think journals have a role to play here. And whether you're a reviewer or a journal editor, there are definitely things that could happen in the future that I think would be good for the entire community on that front. Now, under what conditions and in what format, those questions have yet to be decided. But that would be my answer to that question. Oops.
Sorry, I started playing with my mic. Thanks, Susie, for answering this question. And now Bertil also joined us. It's very nice to meet you in this format of conference, given that some of us didn't have a chance to meet you in person before, and we would really love to hear your comments.
Well, first of all, thank you very much for inviting me here. And thank you to both Angela and Susie for their great talk. Actually, there are a lot of opinions that I've already said by Emily also, which I was feeling about the real interest of using those types of standards in order to first maybe help students also define what are the important keys that they have to be careful about. Because I know I started doing really properly EEG during my thesis, and I felt that I was completely lost in a sea of information, and I really didn't know what information was really important and really relevant, and what information could impact my data and my results. So I started doing some kind of personal meta-analysis, and so that actually everybody was doing different things, so they didn't help me at all. And then I wanted to mention also the fact that I thought it was really interesting that Susie mentioned aviation in our talk, because I was actually giving a talk class this morning to students in aeronautics and telling them about cognitive biases. So we've talked a bit about cognitive biases at the beginning of this conference. It was on Monday afternoon, I believe. And this is really fun to find that, to understand that we are subject to all those cognitive biases also during the analysis of our data. For example, we tend to have like those conformity or authority biases, where we believe that as people who are really well known and renowned in the field, as some people said that, we will have to follow exactly the same thing and just maybe not confirm it by ourselves. And using those kind of checklists could help us confirm the accuracy of about what everybody says. And I ended up at some point when I started doing EEG again, at the beginning of my thesis, I was wondering why some people were using those parameters instead of others. And some researchers were telling me just, well, everybody's doing it like it, everybody's doing this like it, so you just have to follow them and to follow what they are doing, you know. And I ended up wondering why I had to do it like this, and again the impact on the results that I would publish afterwards. And finally, also, I believe that there is some kind of complacency bias sometimes towards maybe the analysis that we use, and towards the softwares that we use also. And there are so many informations which are given and which we can change that we tend to just leave the default settings at some point and just be complacent towards the system. And I believe that maybe publishing those kind of checklists along with maybe the codes that we used in open access would allow for a better verification of our results by the whole community.
So one of our goals is actually to incorporate not just the checklist where you fill in the items for like what kind of filter was it, and if you say it's this kind of filter, then you get 1 box. If you say it's that kind of filter, then you get 2 boxes to fill in, you know. But like a decision tree, that if you've made one decision, there's more information to fill, and if you make a different decision, then there's different information to fill, right? And that can act as a learning tool, because as you toggle the decisions, you can realize how that cascades. But we also want the community to come together and volunteer their best examples. So if you've written a paper where you've described your filters absolutely perfectly, right, we want to actually put your text in our template as a model for how you can describe that. Now, obviously, this is community consultation, so you might think you've done it perfectly, and someone else might say, yeah, but you've left out this bit, which means like you can volunteer your text to be a shining example for the rest of us to learn from, or a mediocre example for the rest of us also to learn from. Either way, we're hoping that as a community, we can build it as a tool that has that sort of flexibility to contribute to training the next generation of scholars, as well as keeping those of our scholars who have a bit of experience in this field, helping them not to just miss something when they're in a hurry.
Thank you so much from my side as well, Bertil, and I can just say that I also personally started facing these issues the moment I started using, as a doctorate student, basically EEG methodology, and as we progressed, especially with this project that we were all involved in with the meta-analytical approach, basically it just deepened down the understanding how many different things we need to decide further and so on. But we'll continue. I just really want to bring on a stage our last panel discussant. So again, for the organizers, if you could please bring on the stage Giorgio Ganis, we would love to hear what he has to say about this project and the vision that we are trying to present here. Hello.
I have too many videos to watch, so I'm going to try to share my screen. I have a couple of
Yeah,
slides.
so
you can take me off, because I think we have too many videos if we share a screen.
Yes, exactly. So for the conference organizers, because Giorgio has a few slides that he would like to present, could you please take, I don't know how many people need to be on stage, if only 2, if you could leave 2 of us on the stage in that case, sorry. Thank you. They say that you should be able to share screen now.
Oh.
Yeah, okay, great.
Oops, sorry. Okay, can you see that? All right, great. Awesome.
Yes. Yeah.
Okay, so, oops. Oh, I'm getting some weird. One sec. Okay. Okay, so I was just asked to spend 5 minutes and share my thoughts on these 2 talks. And by the way, I really enjoyed both of them, so thank you for giving them. Sorry, I think I have to. I think I got the wrong window here. Sorry about that. I'm trying to share the right thing. Can you see this? Sorry, guys. Can you see this?
Yes, we can. Sorry.
I'm having a problem with advancing with this. Okay, can you see that?
Yeah. ARTEM-IS roundtable.
Sorry about that. Okay, so as we saw from the talk that Angela gave, right? Anyone who has tried to actually do a meta-analysis with MEG or EEG data knows that it is super difficult, right? So for two reasons, right? And the first one is incomplete information. So a lot of the papers are missing important bits of information. And the second one, which is related but not the same thing really, is parameter variability in cases where there shouldn't be any variability, right? For example, filtering details and so on. So in fact, when I review papers, even nowadays, I review lots of papers, EEG, some MEG as well. I always find that there is a lot of missing information there, right? And this is even despite the fact that over the years, there have been a number of published recommendations, okay? So some famous papers where they tell you basically what you should do. But it looks like despite that, people are not really adopting it, okay? So I totally agree with the idea of ARTEM-IS that we need something better, right? And so we need something which I tend to call like algorithmic guidelines, okay? These are basically guidelines that is not just a list of things you should do, but again, it's they come also with some kind of an algorithm to guide you to this set of choices, sequence of choices, and by the end, basically, of this sequence, you're done with your method section, basically, okay? So I think that the ARTEM-IS ERP template is a good step in this direction, at least for ERP research. Okay, so that said, we've seen over the last few days that there are already some existing and evolving guidelines for MEG, right? So we know that these were typically generated for MRI originally, but they've been expanded for MEG and EEG as well. And we saw Ina's talk where she talked about the Comidas MEG, right? That's probably the most recent one. We saw that there is a Comidas MEG document on MEG best practice and sharing. And also, I was looking at just a couple of days ago, basically at the Comidas MEG spreadsheet, which has almost 200 fields, okay? That's on the OSF side. So this list, of course, this spreadsheet could be used also to create an eComidas checklist app for MEG, like the one that Remy showed us for the eComidas PET, for example, right? Okay. So all of this is work in progress. Everybody's working towards it, but the situation is quite fluid, okay? And so I think one question that we have to ask, and that you guys have already asked, right, is how do we coordinate these efforts, okay? Different efforts. It's not trivial. It's a bit of a delicate situation sometimes, right? So I think perhaps the first question to ask is whether these different efforts or proposals, do they serve the same purpose, right? Or perhaps do they serve somewhat different purposes? If they do serve the same purpose, right, I think that it will be efficient to coordinate somehow, right? Otherwise, things are very inefficient, right? So one could think of early coordination. So, right now where we are at the draft stage will be a good time to coordinate, right? Or some people might say, let's just do a natural evolution scheme where, we let them evolve independently. And then, people are going to basically choose one in a winner-take-all kind of situation, okay? So this is one idea that by seeing what Remy said a couple of days ago, I was thinking that perhaps ARTEM-IS, right, the template that you already have on the site there, could perhaps inform, right, given that it was already based on a lot of data, could inform basically an eComidas MEG app, perhaps, okay? And I really like that kind of app because it gives you basically a sequence of choices, and I was wondering if that could be expanded, perhaps, okay? Okay, one last thing is that the ERP situation is quite simple, and that's the one that was used for the ARTEM-IS, in this example, right? But as we know, right, the number of parameters and decision you can make becomes much, much higher when you have more complex data analysis, time frequency analysis, inverse solutions, source connectivity, and all that. For us who review these papers, we know that the number of choices become quite alarming, actually, when you look at the papers, right? But I think regardless of the system that we end up choosing, it should be flexible, right? And be able to grow to incorporate all these new measures, methods, and analyses rather than being a patchwork of different templates. That's at least what I think. Okay, guys, so I'm gonna, that's all I have to share for now. And it would be great to hear what people have to say.
So I love, thank you very much for your positive thoughts on our very early stage draft. I think we're all at this conference in particular thinking in very similar directions of coordinating our efforts to make sure that we can maximize the value of the tools that we're all building independently by bringing them together and coordinating the way they talk to each other. We don't pretend to be the technicalist of people in the way that we're designing this as a functioning tool, but our experience of the meta-analysis has given us that item level specificity where we think we can help people not make those mistakes. And we've been looking at some of these other tools like the big Kobidas spreadsheet as well, and we see some similarities and we also see some differences. So as I mentioned in my very short talk, one of the rules from across the checklist community is that people won't use them if they have to do the same thing twice. So you are indeed correct. If we are duplicating our efforts, then we're going to disenfranchise people from one or another, and that's wasted effort. So we thought we would bring out our very early stage nascent egg baby to figure out how it's going to live in the world in a community of other stuff. So it's a really exciting time for us to be here and having these coordination chats. It's just such an exciting community to be part of, and we're like so thankful to the organizers for hosting us here.
Yeah, I can only join and support in everything that Susie said so far. And I would also like to ask organizers if they can bring Angela on stage. And maybe it's the time now to start addressing some of the questions that we have in the Ask a Question session. And we have like a few still that we didn't address as we go through, because both Angela and Susie were trying to address some of the questions that were popping up as we were going through through the session. So for the organizers, again, could you please bring us Angela back so that we can start going through the questions we got so far. And as for the discussants, it would be lovely for you to stay on board so we can continue discussion with the rest of the crowd. Thank you. Okay, so Susie, some of the questions are directly targeted at you. So if you could start checking or getting those questions and responding to them. Some of the, just 1 second.
I think we've
to open them.
just answered the first one already. I suspect ideally we want to get journals interested, especially if we can make them realize they don't have to come up with their own checklist. Yes. So just returning to that idea about mandatory enforceability, we genuinely believe that if the tool is designed in such a way that it's easy to use and hard to make mistakes in, it becomes a lot easier for a journal to be able to just check that the validation check within the tool says, yes, there are no internal inconsistencies. And that becomes a much easier check for a journal editorial board to say, oh, well, if it's got the green light from inside the app or the form or the internal form logic, if it's got the green line there, then what they've done may make no human sense, but at least they've described it correctly. So we know that people do a wide variety of things when they conduct their EEG studies. We have seen everything. It's quite extraordinary. But we hope that by making it a little bit more systematic, it becomes more checkable, more and easier, both for researchers to use and for others to engage with and check. So I hope I've answered that question. I think the next one is actually for Angela.
Yes, I think so as well. So Angela, you are with us?
Yeah. Okay.
Yeah. So we are going to ask a question. So next one, it seems to me also.
Okay, so the question is, when you say that the N400 is always there, I wonder about the word the. Are you sure that the effect reported is always one and the same phenomenon, that they have one and the same cortical source? And how do you know that what we call the N400 is the same biological phenomenon? Actually, I could bet that it is not. And it was one of the dilemmas that we had when we were discussing how to go about the systematic review. And the agreement in the end was that anything that was called the N400 and passed as N400 by the reviewers was put in our systematic review. But it is probably not the same thing. And some of the studies had very unique study designs that I'm not sure would elicit the same thing as the more conventional mismatch N400 studies. So we just tried to not go into that by relying on that if it was called by as the N400 by the scientific community and passed peer review like that, we didn't go further into detail, but it is probably not the same thing. And in general, the N400 is not one thing, probably.
Angela, you did have a very specific set of criteria, though, for choosing those N400 studies, though, right? It was a very specific set of tasks that were included. So it wasn't just any paper that said the N400. You focused on a very specific set of experimental manipulations that likely were somewhat similar in terms of the type of N400 that they elicited.
We excluded some of the stuff, and we excluded also some of the populations and so on to keep it more convenient, more consistent, sorry. But still, I'm not sure that what was left inside the box in the end would be the same thing. But we tried to make it as consistent as possible. Okay, so the next question.
The next one, I think, again is. The next one is from Aina. Yes.
Yeah, she is unfortunately not here anymore, but maybe somebody else is the answer as well. Actually, that was one of the challenging things to analyze because there is inconsistency. Some people say linked reference and they refer to average, and others say linked and refer to physically linked. So our strategy was that if somebody says that they recorded with the linked reference, we treated it as physically linked. And if they talk about re-referencing linked reference, then we would consider it an offline re-referencing to average of 2 earlobes, for example. And there were a few of the studies in our sample, but I think if we look at the date where these studies come from, more of them were from the earlier time. And for the more recent ones, we are not sure whether they actually used physically linked earlobes or they just didn't describe what they did in an unambiguous way. So they led us to conclude that it's actually a physical linking reference. This was a challenge with some other things in addition to the reference that we had to discuss and decide about what we think that the researchers did. If they say, so we recorded with the linked reference, we cannot be 100% sure whether that's re-referencing or it's an online reference or what. And if it is an offline reference, what happens before that, what was the original online reference. So we had a suggestion at the ESCOP conference where we were presenting why we did so much work by hand and took so much effort to pick through papers manually when we could write some fancy code and it would sort out everything automatically and extract all of the information from the papers. And we were told that that's something that's more common in fMRI. I don't know. But for us, it was very difficult as humans who devoted time to really pick out all the details. And I think if we had software, it would have probably been less accurate. Okay, I think the next one is for Susie.
Oh, right.
Yes, the next one is definitely for Susie.
In medicine and aviation, it is clear that these are skills for the whole professional career, how to motivate PhD students that have a short neuroscience careers to invest in that. Whoa, good one. If it's easier, people will use it. So that would be the short answer. And when I say easier, I don't expect this to be a tool that people laboriously pore over one item at a time. We expect that, given the highly software-driven nature of a lot of the processes and procedures we do, these should all be spat out automatically by the software that you use, but in a standardized format so that it doesn't matter if you were using one software system versus another software system. They should all be able to spit out a little mini report in the required format, just the way that people are working towards in terms of file naming conventions and these kinds of things for large data archives, but also the methodological details. There are very few fields in our form that technically require being filled by hand, and those would be the ones on how did you make that decision, which is kind of critical for understanding whether or not a measurement that's being reported is a data-driven or algorithmically generated time window, for example, or whether it was one that was based on something that, a component time window that your grandmother used to talk about. Lab traditions being what they are, it's very helpful to have those details in the methodological record. So for juniors, you're doing this stuff anyway. When you make the decision, it should be easy for you to document that in one way or another. And we should not be offloading all of that documentation process to the last 5 minutes before we submit our manuscripts. It's much harder to do that way around. And even if you do have peculiar grandmother inherited lab traditions, you can hand them down by handing over your copy of the spreadsheet. And then your juniors know the procedure that they're following or deviating from. So I think for juniors, it's actually both a learning tool and a helpful backup in their work, and can save them time, the time that many of us have spent in our first EEG study tearing out our hair saying, but how do I decide which to do, and is that even possible? Yeah, so if the tool helps you.
Thank you. Thank you so much, Susie, because we are coming very close to wrapping this up. I know there are two questions for Angela. Yes, we will definitely wrap up. This is the answer first to the organizers. We have two questions for Angela and then one for Susie. They are answering these three final questions. I will just tell everyone that I will be inviting you for the gathering crowd session next to the apple tree. Right after this session, and then a month after from today, basically it's 5th of November, we'll invite all of you who are interested, who got interested in this project, to basically continue talking about all of this. So as they answer into your question, I will be posting both of these further invites. So Angela, if you could please take over the next two questions, and then the final one is for Susie. Thank you.
Let me just check. So one question is about the sampling rates, whether we looked at the sample rates as well. And I assume the other question is about whether we looked at the neural electromagnetic ontologies and consider the details listed there. So we did not look at the sampling rates, and I was not familiar with NEMO until now, and I checked it out in the meantime. We did not look at all of these things, but we were also we already had 74 properties, and more ideas kept coming up, and probably we would never finish this review if we kept adding more, but there were many relevant things that were left out from the systematic review. So there were a lot of other fun things to look at as well, but just didn't get the chance because this already lasted for 2 years or something like that. So it would be just, it would last many more if we would include that as well. And it would be really interesting to see. And Susie?
So I think that we've got one last question. Someone was hoping they'd be able to join us on stage, but I think we're very close to time, so we might not have time to coordinate bringing someone up with us. And this is the question: is the significance of the checklists in surgery and aviation more pronounced due to the fact that of what is at stake? I think it's easy to make light of this idea that if you're a pilot, there are 400 lives in the back of your plane, and if you're a surgeon, there may only be just one, but you know, it's entirely your fault if they don't make it off the table. However, what we have to remember is that we don't always know the future uses of our work. And if we're putting junk into the scientific record in one way or another, it may have negative consequences for the lives of other people. And we have to ask ourselves the very rational question: is the work that we do less important than flying a bus? And if it is, maybe we should reconsider our life choices. But if we think we're contributing something genuine to the scientific record, we should contribute all of what we've done, because it's valuable and valid and important, and there may be future uses that do actually concern the lives of other humans in the future. So I think if we're doing science, we should do it scientifically.
Yeah, and in that note, we should probably wrap up this whole session. Again, many thanks to the organizers for inviting us to be part of this excellent, absolutely excellent and amazing conference. Many thanks to Angela and Susie for sharing all this knowledge that we as a team gathered so far. And a huge thanks to Emily Bertil and Giorgio for joining us with their discussion sessions and views on this project. So I promised, and I already posted, there is a link to a gathering area. So if you would like to continue talking more about this in a more informal way, virtual though, let's meet next to the apple tree. And I also posted the link for all of us or whoever is interested in to meet through the Zoom session in a month from now. Thank you all very much for joining and being part of this session today.
Thanks to our discussants as well. It's been great having you here with us.
Thank you so much. And okay. Mm-hmm.